All right, moving on to example 3. The shape of the distribution of the time required to get an oil change at a 10-minute oil change business is unknown. Again, important concept to note. However, we know that the mean time is 11.4 minutes and the standard deviation is 3.2 minutes. So to compute the probabilities about the sample mean, again, the sample mean, using a normal model, what sample size would be required? Well, we would need n to be at least 30 in order for us to use the normal model to figure out what's going on. So what is the probability a random sample of 40, so we've got n is greater than or equal to 30, gives us an average time of less than 11 minutes for your 10-minute oil change. So we want to find the probability that the average is less than 11. So normal CDF, again, no lower boundary there, so make it really, really low. Upper boundary of 11 minutes. The mean from the previous page is 11.4 minutes, and our standard deviation was 3.2. We're going to divide, however, by the square root of 40, our sample size, to adjust for the fact that this will be normally distributed based on our sample size being greater than or equal to 30. Okay, so again, typing that into your calculator should get a probability of 0.2146. Okay, well, what if we change that up just a little bit? So still a sample of 40 oil changes, but this time we want to have an average time of less than 10 minutes. So what's the probability that the 10-minute oil change place is averaging under 10 minutes to get an oil change done? So normal CDF, everything stays the same as above, except for our upper bound changes to a 10-minute limit instead of 11 minutes. Our sample size is still 40 oil changes. So the probability that happens is 0.028. Okay, and then the last question in this example. So on a typical Saturday, 40 oil changes are performed between 10 and noon. Suppose the manager offers an incentive of $50 per employee if they meet a certain goal. The goal is established in the following way. Using those 40 oil changes that we just talked about as the random sample, what mean oil change time would there be a 10% chance of being at or below? Okay, so in other words, he wants them to shorten the amount of time where oil changes are happening. And so we are looking now at being in this fastest 10 minutes. So remember, on a time scale here, if this is our mean in the middle of 11.4 minutes, we want to be on the low end, which is down there. Okay, so this is the 10% we're looking at, and we want to know what is that average time that we want to get to. So again, if we're going to find x bar, we need to use our inverse normal function. Our area would be 10%, that's the left tail. Mean of 11.4, standard deviation 3.2 over the square root of 40. And this turns out to be 10.75 minutes. Okay, or if you're going to go 10 in terms of minutes and seconds, 0.75 minutes, 3/4 of a minute would be 45 seconds. Okay, so 10 minutes and 45 seconds would be the goal, that they need to be faster than that on average for 40 oil changes in order for an employee to get that bonus.